Good morning. Myself, Dr. Ritesh Kumar Saraswat, Assistant Professor in Electronics and in Communication Engineering Department of MLB Textile and Engineering College, Bhilwara. In continuation of previous lecture of sampling process, today we will discuss about the numerical problem of sampling process. So let us start the numerical first, where the determine the Nyquist rate and Nyquist interval for given continuous time signal x of t equals to 1 upon 2 pi cos 2000 pi t multiplied with the sine of 1000 pi t. So as per the given question, x of t is the 1 upon 2 pi cos 2000 pi t into sine 1000 pi t may be converted into sine a plus b and sine a minus b. Because of that, the expression is given as a sine a cos b. So by using the particular formula, it may be represented as the sine 2000 pi plus 1000 pi t plus sine 2000 minus 1000 pi t. Okay, so the final expression is the 1 upon 2 pi sine 3000 pi t plus sine 1000 pi t. So as we observed in the expression, there are the two frequency component. There is the 3000 pi t and the another one is the 1000 pi t. So there are the two frequency component, one 3000 pi t and the 1000 pi t. So maximum frequency component, when we compare the two 3000 pi and the 1000 pi, the maximum frequency component is the omega m equals to 3000 pi. 3000 pi. So the fm equals to omega m upon 2 pi. So the frequency will be the 1500 hertz. So as we know that the Nyquist rate is the f of s equals to twice of the maximum frequency component in the given signal x of t. So the maximum frequency component is the 1500 hertz and the double of the fm is known as the Nyquist rate. So f of x equals to 2 into 1500, that is equals to 3000 hertz. That is known as the Nyquist rate. The Nyquist interval is the basically reciprocal of the Nyquist rate. So Ts equals to 1 upon f of s, that is the 1 upon 3000 second. Next we will discuss the advantage of digital communication over analog communication. The digital communication is more efficient, rugged than analog communication because it can withstand channel noise and distortion much better as long as the noise and the distortion are within limits. The second one point is the low error rates. Digital signal may be coded to yield extremely low error rates. Digital hardware implementation is more flexible. The third one point is digital communication is more efficient than analog communication in a realizing the exchange of SNR for bandwidth. So in case of digital communication system, SNR is much more improved form as compared to analog communication, because of since SNR is known as the ratio of signal to noise ratio. SNR SNR basically defined as the signal to noise ratio. In case of digital communication, noise is in decreasing form, so ultimately SNR will be improved form because it is a reciprocal process, inversely proportional ratio between the SNR and the noise. Next one, the easy and inexpensive. Digital signal storage is relatively easy and inexpensive. The multiplexing of several digital signal are more easier and efficient. So these are the such advantage of the digital communication over the analog communication. That's why we are mostly prefer the digital communication as compared to analog communication. Next one section is the PCM, pulse code modulation. So firstly observe the basic block diagram of pulse code modulation, where the input is the analog signal or continuous time signal or modulating signal. Next given to the section of the sampler, next given to the quantizer, next given to the encoder, and finally given to the communication channel. So basically this one section is the transmitter section of the pulse code modulation, consisting the three basic blocks: sampler, quantizer, and encoder. And this one section is known as the receiver section of the pulse code modulation, consisting the three blocks: quantizer, decoder, and the filter, and finally output the modulated or demodulated signal. These are comparable between the m of t, and the output of the demodulator is the m dash of the t. So firstly, consider the transmitter section of the pulse code modulation. The first one section is the sampler. Sampler basically, as we are studied earlier, the sampler is provided the discrete form of the continuous time signal m of t. That means it is provide the sampled version of the m of t. The sampled version is given to the quantizer. As the name is indicated, quantizer, that means the quantize the particular level of the given sample. The sample are quantized by using the quantizer section. The quantizer will provide the particular level, the quantized level, and the output is the quantized PAM, pulse amplitude modulated waveform of the quantized PAM, and this quantized signal is given to the encoder. Basically, the work or the purpose of the encoder is provide the particular coding of the given level. So the label is given to the encoder. Encoder is provided the coded form, digitally encoded form, which is consist in the 0 1 form. It may be a 0, it may be a 1, given the sequence of the 0 1 formation. And this digitally encoded signal or the 0 1 formation is transmitted by using the transmitted channel in the communication channel. After that, at the receiver section, the encoded signal is initially given to the quantizer, provided the quantized level, next given to the decoder. Decoder basically the reciprocal process of the encoder. So decoder is decode the encoded or decoded signal, and next given to the filter. Filter is provided the modulated or the analog continuous signal. So the finally output given is the m dash of t. So compare in analysis of the PCM system, compare the m of t and the m dash of t, and identify the particular response or the performance of the pulse code modulation. So this is the basic block diagram of the pulse code modulation. Thank you.